harmonics, we talked about sound and the properties of sound and how to describe it, right? And we talked about two different ways of describing a sound event. First way is in the time domain. This is called the envelope of a sound in the time domain. ADSR. For attack, decay, sustain, and release. These are the four basic areas that we talk about when we're talking about a sound event in the time domain. Right now, we also talked about the fact that you could describe it in the time domain or you could describe it as a relationship to frequencies. And we came up with this concept that all sound could be broken down into building blocks, which are sinusoidal waves at different frequencies and amplitudes and phases. And if you did that, you could add them together somehow to create any sort of complex wave that you want. I gave the example of a square wave, which is not exactly a simple sine wave. So just to remind you guys, right, we had a square wave. And then we started thinking just without any math, without any of that stuff, just does it make sense? So we started talking, well, there's one wave here that would fit in there. That's great. So that might be our first sine wave that we'd start with. And then we'd need higher frequencies to start filling in the corners. And eventually you get something that looks like this. And then you keep adding and adding and adding more higher frequencies at different amplitudes. And eventually you could actually recreate the exact square wave. Of course, that would take an infinite amount of terms to add together, all going up in frequency and getting quieter as they go up. That's what's called the spectrum. So this first sine wave that fits most closely into the wave we're trying to create is called a fundamental. And the fundamental frequency of a sound has two important qualities to remember. First one is it's the loudest in the sound. Second of all, it tells us, human beings, what pitch we're talking about. The higher frequencies that are needed to add together to the first frequency are called the harmonic structure of a sound. And it basically dictates what the timbre is of the sound. The first frequency is the fundamental, and it's the loudest, and it tells us what pitch we're talking about. And it's what the other harmonic structure above it is built on. The frequencies above the first frequency are called harmonics, and the amount of harmonics and how loud they are and which ones they are determine the quality of the sound or timbre. Basically what it tells us is what instrument's making that note. So if I played middle C on piano, it would have the same fundamental as if I sang middle C. The difference is the upper harmonics above that are different for the piano and for my voice, and that tells the listener it's a voice or it's a piano. The harmonics have two qualities as well that are important to remember. First quality that they have is that they get quieter as they go up, meaning they decrease in amplitude. And the second is quality of sound. In the time domain, this piano chord that we played could be described like this, with an envelope, or it could be described like this, as a fundamental frequency and harmonic structure. So, they're important to understand that these two relate. And if you change one, you change the other. So if I were to change this envelope and make the attack less and play the piano quieter, it's going to affect this. And what harmonics and how loud they are. And everybody knows that when you play an acoustic guitar loud or quiet, or hit a drum loud or quiet, or a piano loud or quiet, it sounds different. Even though it's the same chord or the same note, it'll sound to have a different character to it a little bit because you're actually exciting it more by putting more energy into the pluck of the string, which then resonates longer and more frequencies in the body of the guitar. So that's how resonant frequencies tie into this whole thing in terms of sound generation of creating a harmonic structure and a fundamental or a time domain event of a sound. So that's the main thing we discussed on the second week, is how sound was really generated by instruments and what it really meant. In our world, when we're talking about EQs and recording art, we're almost always talking about the frequency domain picture of a sound. But it's really important, really, really important to remember that these two things are linked together. Change one, change the other. because they're just descriptions of a sound event. These are all man-made descriptions, even though they're physically true, but they're descriptions that we can utilize to understand how to manipulate sound. In reality, a sound event happens with a piano being hit and you hear a sound. Now you've got two ways to describe that.